In today's lesson, we're going to be graphing linear equations. We're going to start by reviewing the forms of linear equations. From there, we're going to find solutions to given equations, and finally we're going to graph those solutions onto coordinate planes. You'll need a piece of graph paper and a piece of notebook paper to take notes during this lesson. Let's start by reviewing the forms of linear equations. The first form that we're going to look at today is standard form. Now here's an example of a standard form equation, 3x plus 2y equals 6. Notice in this form that both the x variable and the y variable are on the same side. And that's how you identify standard form, when the x and y are on the same side and the constant, the 6 in this case, has been isolated. Now function form changes slightly. We simply take an equation and solve it for one of the variables. Typically we're going to solve for the y. And in this case, when we do solve for the y becomes the output of the equation or function that we're working with. And if y is the output, then our x variable represents the input. Now that we have reviewed the two forms of linear equations, standard form and function form, let's take a look at how to find the solutions to equations. We're going to start with an equation in standard form, 3x plus 2y equals 6. My first move will be to begin to take this equation and put it into function form. Now typically we're going to solve for y, so we'll follow that same pattern today and begin to isolate the y variable. First move will be to subtract 3x from both sides. This yields 2y equals 6 minus 3x. Now we will divide both sides by 2. And since the right side has two terms, I need to divide both of those terms by 2 to keep the equation true. So the equation in standard form is y equals 3 minus 3 over 2 x. Now, to find the solutions, we're going to set up an input-output table, or a data table. The left column is our x values, and in the right column, we're going to write down the corresponding y values, or the output. Now, other terms for input are domain and independent variable. Because we're working with the independent variable in the first example, we get to choose these values. So the first x will be negative 2. Now, to find the solutions, what I'm going to do is write down the equation and substitute into the equation my x value. So 3 minus 3 over 2. And where the x is, I'm going to replace the x with a set of parentheses. Now, follow the order of operations. 3 plus 3 is going to be 6, so the output will be 6 when x is a negative 2. I'm going to continue that same pattern, always showing my work. 3 minus 3 over 2 times the x value of 0. And once again, this is the minimum amount of work that needs to be shown. You can always show more. So 3 halves times 0 is 0, so the output is 3. The next input, or independent variable, will be 1. Once again, I write down the expression, follow the order of operations, and evaluate that expression for the x value of 1. And I find that 3 minus 1.5 is 1.5. The final solution that we're going to find today has an x value of 4. Once again, write down the expression, replacing the x variable with a set of parentheses, and inside that set of parentheses, placing my x value of 4. I'm going to cancel here. This gives me a 2 in this position, a 1 in the denominator. 3 minus 6 is going to give me a value of negative 3 when x is 4. Now, because these are solutions, what we can do is check these solutions into the original equation. So let's go ahead and do that. Let's take the first solution, which was negative 2, 6, and go back to the standard form equation and replace the x and the y with our values that we determined in the table. So the x value was a negative 2. The y value was a 6. Now we simply evaluate the left side to see if it equals 6. So 3 times negative 2 is a negative 6 product, plus a positive 12. And we recall that 12 minus 6 is 6. So in this case, this is a solution. Now, we have reviewed the forms of linear equations. We've found solutions to linear equations. Now we're going to graph those solutions onto a coordinate plane. So the first thing I want to do in this case is label the x and y axes. The x-axis is always the horizontal axis. We're going to label that x. The y-axis is always the vertical axis, so we will always label that y. Notice on the y scale I'm counting by ones, and on the x scale I'm counting by a half. Once I've set up my scales on both the x and y axes and labeled them, I look at my data table. My first ordered pair is -2, 6. I'm going to use the red line to represent the x value. So I'm going to move the x value to over where it is -2. So everywhere on this red line, the x value is -2. Now the y value is a 6. So I'm going to use the green line to represent the line where all the y values are 6. So where those two lines intersect is the point -2, 6. Let's look at our next point, 0, 3. So move my x value to where it's 0. That's sitting on the y-axis. Move the y value down to where it's 3. And at that intersection point lies the point x is 0 and y is 3. Our next point is at 1 and 1.5. Moving my x value to 1. My y value to 1.5. That intersection point is the point 1, 1.5. The final point was at 4, -3. I follow the same pattern, finding the x value of 4, move the y value down, and that intersection point should be the point x is 4, y is a -3. Now notice in this case that the points fall into a nice straight line, and that's another indicator that we have not made a mistake with our solution set that we found, because they all fit the pattern, a nice straight line. Let's look at another example. Recently, gas in the St. Louis area was $2.89 per gallon. We're going to write a model that gives the cost of purchasing gas at $2.89. Now we know the cost is going to be related to the number of gallons that we purchase, and each of those gallons is $2.89. So our model is going to be $2.89 times the number of gallons that we purchase. Now, since the cost is going to change, we're going to use a y value to represent the cost. The cost of each gallon is going to be constant, so the $2.89 is going to remain the same during the situation, but the number of gallons of gas that we purchase will change, so we'll call that x. Now we're going to use the model to find 4 possible combinations for gasoline that we could purchase. So for example, we could go to the gas station and we could purchase 1 gallon of gas. And if we purchased 1 gallon of gas, that would be $2.89. So our point would be 1 gallon of gas at $2.89. We might go to the gas station again and purchase 2 gallons of gas. And if we purchase 2 gallons of gas, then the cost of that would be $2.89 times the number of gallons that we're purchasing, in this case 2. And that would give us a total cost of $5.78. We could go back to that gas station and purchase 5 gallons of gas. And if we purchase 5 gallons of gas, that would be $2.89 for each of the gallons. In this case, we're going to purchase 5 gallons of gas. $2.89 times 5 gives us a cost of $14.45. So you can see we can find the solutions using a data table, or we can set up ordered pairs. X value first, y value second. The final set of possibilities will be 10 gallons of gas. So 10 gallons of gas is going to be $28.90. Now let's take a look at our situation. We found 4 possibilities different amounts of gas that we've purchased and their corresponding prices. It says to identify the domain. In this case, we know that the domain is the number of gallons of gas that we're purchasing, but they want us to be a little more specific. They want us to talk about the numbers that we can use. Can we use a 1.5? Can we use a -2? Well, we know we can't purchase -2 gallons of gas, and the least amount that we could purchase would be 0. So we want the x values to all be greater than or equal to 0. So we might go to the gas station and not purchase gas at all. Or we might go and purchase only a half a gallon, or 1 gallon, or 2.5 gallons, or 3 5/8 of a gallon. Likewise, the range we know is the cost of the gas in dollars. And the least amount of gas that we can purchase is 0, and that would correspond to a cost of 0. So all the y values must be greater than or equal to 0. So from this point on, when we begin to identify the domain and range, not only are we going to identify what the domain is, the number of gallons, but we're also going to talk about the acceptable values for the domain. X has to be greater than or equal to 0. Now there is an upper limit according to the size of your gas tank, but because all cars are different, we're not going to talk about the upper range or upper limit for our domain and range. So we've reviewed the forms of linear equations. We have reviewed finding solutions to linear equations. We've also graphed a linear equation onto a coordinate plane. Please bring your notes to class tomorrow. We will discuss this lesson and begin our activity for today.